All right, so here's the standard form equation for an ellipse. It looks like this. X minus h squared over a squared plus y minus k squared over b squared equals 1. Do you remember that? Yeah. Actually, I'm teaching that today in my Algebra 2 class. Okay, so what makes an ellipse an ellipse? Well, an ellipse has two foci. Let's assume that A is bigger than B. Okay, when B is bigger than A, just things kind of change up a little bit. So the center of this ellipse is going to be exactly what you think it is. Okay, it's going to be HK. So it's the numbers from the top and they're opposites, right? So positive H, positive K. This also has vertices. Now the Algebra 2 book talks about covertices. This book doesn't. They just leave it off, okay? So the covertices are going to be where it opens up the biggest. So an ellipse is going to go bigger either left and right or bigger up and down. In this case, I said A was bigger than B. So then our vertices would then be at H plus and minus A, comma K. All right? Okay, the major axis has a length of 2A. The minor axis has a length of 2B. Or not 2B. Every time. 2B. If A and B are equal to each other, you get a circle. Okay? The other thing is we also have to find the foci. The foci are always on the major axis, and they are a distance of C from the center. A distance of C from the center. And so the way that you find it is you're going to use this. C squared equals A squared minus B squared.
Are we given that?
No. You have to memorize all these formulas.
Thanks.
Algebra 2 does too. No, they're not happy either. So there you go. So the ellipse, in the middle of an ellipse, it has a plus. I always think about it as you're adding, you're bringing it together to form an ellipse, which is an oval. The hyperbola, which we'll learn tomorrow, is a minus. It like separates it, subtracts it out. Okay? So the plus is in the equation, but the foci has a minus in the equation, and then it's reversed for the hyperbola.
What is the C from center?
Yes, it's C is a distance of C from the center.
Oh, okay.
Yeah, so the foci are a distance of C from the center. So if we were going to then figure out what the foci are, the foci would then be at the point here. It'd be H plus or minus C, comma K. But you don't have to memorize all that. You just count and you figure it out, okay? Okay, so here we go. Let's do some. By the way, one last thing. If B is bigger than A, then your ellipse is going to be longer going up and down. So things will change a little bit. C squared will equal B squared minus A squared. It's always the bigger number minus the smaller number. And then your foci would then be at H and then K plus or minus C. Okay, so things change a little bit. Everything just gets reversed. So instead of going a distance of C left and right, you go a distance of C up and down. All right, so the first example is a really basic, easy example, okay? I just want to warm you up a little bit. I know the grid kind of got lost on your page when it printed out. It was weird, huh?
Bummer.
I know. I thought so too. Okay, so here we go. What's the center of this ellipse? The center is H and K. Are there any H and K? The origin, exactly. The center is 0, 0. Boring. This is a boring one, but we like boring sometimes. So let's go ahead and let's plot that. 0, 0, okay? And this is how you graph this ellipse. We're going to go, see the x squared over 25. You're going to go a distance of a in each direction, and that's a squared. So we're going to go a distance of 5 in each direction from the center. Okay, then we're going to go up and down a distance of 4 in each direction. And then you draw your ellipse. It's almost circular. It's pretty close, huh? Okay, and there's the ellipse. And now we're going to answer all their questions, okay? So the vertices are going to be the points that are the farthest away from the center. And in this case, the farthest points away are on the x-axis. They're at plus or minus 5, 0. The Algebra 2 book calls 0 plus or minus 4 the covertices, but this book doesn't seem to care about covertices. The major axis length is the length here. See what I mean? How you don't have to like memorize like 2a or 2b or whatever. You just count it. What's the length of that from -5 to +5? 10. Perfect. What's the length going up and down? 8. Done. You don't have to memorize 2 times b or anything like that. Now the foci are going to be a distance of c away from the center. So we have to use the foci equation. C squared equals big number minus small number. See, even then I'm not like, is it a squared minus b squared? Is it b squared minus a squared? You don't have to think that. Just big number minus small number. So what is c squared? 9. Good. So c is plus or minus 3. Okay, then you have to decide. Is c going to be plus or minus 3 from the center, left and right, or up and down? Left and right, because they're always on the longest side. So the foci would be at plus or minus 3, 0. And we can graph them if we want to. The foci usually don't turn out nice like that. This is kind of a fun one where everything works. There you go. Fun. Do you remember this at all? A little bit? Oh, yeah. Sure, yeah. You guys were in deep convo there.
Yeah.
Talking about how ellipses make the world go round, even though they're oval.
Yeah.
Can we turn the AC down?
Yeah, do it. Next page. Ready? Alrighty. Now, we have moved it. We've moved it off the origin, and we've moved it to a new center. Now, what's that?
-1.
Oh, yeah. So everything's going to come from the center now. Everything. Okay? So here we go. We've got, -1, +4. So go over to -1, +4, and plot your center right there. I like to graph it first and then answer all the questions. All right, so now we're going to go 2 in each direction, side to side, from the center. Not from the origin, but from the center. 2 in each direction. 2 in each direction. What? Oh, square root of 4. Sorry. So a squared is always underneath x, and you go a distance of a in each direction. And then we're going to go up and down a distance of 3. 1, 1, 2, 3. Okay, so we draw our ellipse, and this is an up and down one. Here we go. And now let's answer all these questions over here. Okay, the vertices. The vertices, you can see them on the graph. Do you see the vertices? You can count that here's a vertice right here, and here's a vertice right there. And the first one's at -1, 7, and the other one's at -1, +1. Okay? Let's say you don't have a nice grid like that. All you have to do is everything's coming from the center. It's like this. -1 and 4, we're going to add and subtract 3 to it. Right? 3 up and 3 down from the center. Those are our vertices. Or you can look at the graph and see it. So it's -1, 7, and -1, 1. All right, the major axis length is how long this is. So how long is that? 6. 3 and 3. Good. 6. The minor axis length is the other way, and that has a length of 2 and 2 from the center, so that has a length of 4. And now let's do the foci. So foci are going to be c squared equals big number minus small number. A squared minus b squared or b squared minus a squared, doesn't matter, just the big number minus the small number. So c would then be plus or minus rad 5. Now, yes, that's an ugly number, that's okay. The foci are going to be from the center a distance of rad 5 up and rad 5 down. Here's how you write that. you take the center, you take 4, and you're going to add and subtract rad 5, and you leave it just like that. Okay, it's trickier though when you're not from 0, 0 anymore, right? But everything comes from the center. So you change the center to be what you want it to be. Up and down 3, side to side 2. Yeah?
Where'd you get the -1? The -1, 4 plus or minus 3.
That was for my vertices. So I took -1, 4, and my vertices are 3 up and down, so they're only affecting the y coordinate. The x coordinate didn't change, not for vertices, not for foci. They're all in that same -1. Okay, number 3. Number 3, since I was so hasty, that was our devotions, I didn't get to write down the equation, so here we go. We're going to write standard ellipse form for this equation. Here it is. X squared plus 4y squared plus 6x minus 8y plus 9 equals 0. Okay. So that's a big long string of stuff, right? Yeah. And that does not look like an ellipse. Although if you do know something about how to determine whether it's what conic it is, then you do know that that's an ellipse. But it's not in standard form. So we're going to get it into standard form. And so what we're going to do is we're going to complete the square twice. Yes, twice the fun as parabolas. Okay, so here's what you do. You want to get the x's together. So x squared plus 6x, and then leave a blank there because we're going to complete that square. And then we want to get the y's together, and the y has a 4 in front of the y squared. So you know what I'm going to do? I'm going to factor a 4 out of both of the y values so that I get y squared minus 2y and leave a blank. And then subtract 9 to the other side. Is everybody okay? I did a lot of steps in one. And you could do each step individually, but I figure, you know, it's this late in the game. You guys are all pretty smart. You can do this. Okay. All right, so now we're going to complete the square. So we're going to take half of b, half of 6, which is 3, and square it. And we're going to add 9 to both sides. Okay? Then we're going to take half of -2, which is -1, square that, and you get +1, but you're going to add what to the other side? 4. Okay, be careful there. Make sure you add 4 to the other side. All right, once you've completed the square, now they are perfect square trinomials, so they will factor as one binomial squared. So this one factors as x plus 3 squared. It's always half the middle term. Plus 4 times y minus 1 squared equals -9 plus 9 plus 4 is 4.
Hey, this is probably like a super stupid question.
No?
But it's always like minus when like the one in front of 2y is minus, right? And then it's always plus when the one in front of the other one is plus.
Always.
Okay.
Yep. Oh, yeah, the middle term.
Yeah,
Mhm.
like that's
Always.
when it's like-
Yeah, you take half of 6 is 3 and half of -2 is -1. Mhm.
Okay.
Yep, always.
And then do we need to use the star method with this chapter?
Nope. All right, and then divide everything by 4 because our ellipse equation is equal to 1. And so here we go. Here's our standard form ellipse equation. X plus 3 squared over 4 plus y minus 1 squared over 1. You don't have to write the over 1, but these 4's are reducing, equals 1. So that's really just the first step. And then now you can answer all these questions. Do you feel like we need another one of these? No? Like to go through the center, vertices, all that stuff. We've already done 2 of them. I don't know. You feel like
Do it fast.
do it fast. Okay, we'll do it in a hurry. All right. Oh, I only have you doing, oh, I don't ask you for everything here. Okay, yeah, let's do it. All right, so the center is -3, 1. Bless you. -3, 1's our center. From the center, we're going to go a distance of 2 left and right, because it's the square root of 4. So we go a distance of 2 left and right. Those are going to be our vertices, because that's the longer axis. And then we go a distance up and down of 1. Okay, kind of a smaller ellipse here. All right, so now let's answer the questions. For me, I don't like to go over here and look at what the points are. I like to go from the center, and this time my vertices are going left and right. So I would take the center and I would add and subtract 2 from the x value to go both directions. Or you can just go over here to your grid and find out what those points are. We're looking for these points here and there. You can tell it's the point -1, 1 and it's the point -5, 1. Or you can do this. -3 plus 2 is -1, 1. -3 minus 2 is -5, 1. Whichever way you like to do it, okay? All right, and then the foci are going to be c squared equals big number minus small number. So c would equal plus or minus rad 3. Now remember, they're always on the longer axis here. So from the x, from the center, everything, remember, comes from the center right here. We're going to go a distance of rad 3. So it's -3 plus or minus rad 3, comma 1. Okay? So you're going to add the foci to the center, and you're going to add it to either the x value or the y value, the h or the k, really. And then you move it. You feel pretty confident? Pretty good this year? Yeah, it's easier the second time around, huh? Yeah. Don't call me Care Bear. No. All right. All right. Here we go. Last ones. Last time. So now, these are a little different, as you can see on the last page. Now I give you some information, and you have to come up with the equation of the ellipse, okay? So here we go. Number 4, write an equation for the ellipse given vertices and co-vertices. Oh, this book doesn't really use co-vertices, so, but no, really, it's a good one. It's actually an easier question. All right, so I like to draw a picture of these, or else I just can't visualize it, I can't see it. So we're going to go to 2, 5. 2, 5, and 2, -5. Okay, so those are vertices. The center? This one? Oh, it's for number 5. We're going to have to find the ellipses equation just from the graph. So 2, 5, 2, -5, and then our co-vertices are at 0, 0, and 4. 1, 2, 3, 4. Okay. So here's our ellipse, goes around, looks like that. Okay? So here we go. First of all, let's find the center. Do you see where the center's at? If you draw a pretty good, accurate picture, the center's at 2, 0. I really miss Yo-chan.
He doesn't ever talk in your class.
No, but I miss his presence, though. And he's not going to watch this video.
Smiling at his iPad.
Yes, yes. No, that's Trung. Okay, here we go. We're going to go with x minus 2 squared and y squared. You don't need to write y minus 0. You can if you want to. It doesn't matter. Okay? Now we're going to go and look at the graph. And the distance left and right from the center is a distance of what? 2. Distance left and right is 2 and 2. So we're going to square that number and get 4. You were right. And then up and down is a distance of 5 and 5, up and down. And so this would be 25. Okay, pretty easy? Yeah, that one's an easy one. All right, this one's pretty much the same question, but it's been drawn for you already, so it's actually easier. You try this one. I'm sorry, Jeanette, it's a little warm in here now. Okay, what's the center here? Here it is, it's right in the middle. It's called the center. It's at 2, 1. Okay, and then this is a distance of 3, and that's a distance of 2. So I'm ready to go.
That was really neat for you.
I know. So we have x minus 2 squared over 9 plus y minus 1 squared over 4 equals 1. Yay, did you get it? Doris, yeah, you having the best day ever? Great, okay, let's move on. Number 6. An ellipse with center, horizontal. I think you guys could figure that one out. That's really easy. Let's do a hard one. let's do number 7 and then number 8. Okay, number 7. Write an equation for ellipse, vertices are given, and it goes through this point. This one can be tricky. However, this certain problem is not. But this can be a trickier type of problem. I'll show you why. So if you go to 1, 2, 3, 4, positive 4, negative 4.
First, I'm sorry I missed out. Why do you skip the other one?
Because it was too easy.
Okay.
Major axis has a length of 14, so that's going to be 7. Minor axis is going to be 5 in each direction. It's really easy. Okay. So this one right here, and then it also goes through the point 7, 0. 4, 5, 6. Okay. So this one, you do need to find out what the center is, but you have all the parts there too. Okay. So the center is going to be right here at 4, 0. And then you can count the distances up and down. So the distance here is 4, and the distance out to here is 3. Now, let's go ahead and just write the equation. I'll tell you how this one could be a harder problem, okay? So this would be x minus 4 squared over 9 plus y, oh, I don't need the parentheses on that one, y squared over 16 equals 1. Now, this problem would have been harder if I were given like a point out here, okay? And the way that you would do that is you would set everything up, like we wouldn't have had the a value, so you would have done x minus 4 squared over a squared plus y squared over 16 equals 1, you see it? And then you take that point and you plug it in for x and y and then solve. So it gets a little tricky because that's a hard one to solve. You'd have to subtract that, cross multiply, take the square root, like it's just gross. Okay. Actually, I don't know if you'd have to take the square root. No, you wouldn't, because you're trying to find a squared. All right, last one. And this one's the hardest one of all, which isn't really even that bad. Okay, write an equation for the ellipse given the vertices and the focus. We haven't been given one with a focus yet. Whenever you're given the focus equation, or focus point, you have to use the focus equation. So first, let's start by figuring out where our center is. So this is -1, 1, 2, 3, 4, and then positive 7. 1, 2, 3, 4. So those are our vertices. I like to think of this as this is a total distance of 8 here, right? -1 to 7. So the middle would be 4 away from both of those. So I could just count 1, 2, 3, 4. So that's where my center would be at the point 3, 4. So 3, 4 is my center. You have to be really precise, huh? You have to like count, okay? So it was a whole distance of 8. And so in between would have been 1, 2, 3, 4, or 1, 2, 3, 4 that way. And I like to give you like an even number. You know what I mean? So that it works out that it's halfway between. You're not at like 3.5, 4. That would suck. Okay, and then the focus is at 1, 4. So there's our focus right there. I'm actually going to put it in green. No, oh, that should be a comma. Oh man. 1, 4. I typed this up literally in like 3 minutes, so I did make a mistake, sorry. Okay, so there it is, 1, 4. All right, so let's get our equation going.
How's that focus?
Focus is on the inside of it, so it's gonna look something like this, and that's gonna be the focus.
Okay, so it's just longer on
Yeah, it's longer that way. Yeah. Okay, so here we go. We're gonna go x minus 3 squared over something plus y minus 4 squared over something equals 1. So if you have the center, you can fill in that part for sure. Okay, so now let's go ahead and fill in the rest of it. So A is the distance from the center out to my vertices left and right, and that was a distance of 4, right? So then that would be 16 there. And now we have to figure out what B squared is. So we're going to use the foci equation. C squared equals, which one? A squared minus B squared or B squared minus A squared? Other way. Yeah. A squared minus B squared, because A is the longer axis this time. So it's A squared minus B squared. Okay, now let's talk about what each of these things are. So we know what A squared is. It's 16. B squared is what we're trying to look for. We're trying to fill in B squared right there. What is C squared?
4.
Yeah. C is the distance from the center to the foci. That's a distance of 2. Do you see that? That's why it's really good to graph these nice. So from the center to the foci is a distance of 2. Okay, so we're going to go and do 4. So you subtract 16. You get negative 12 equals negative B squared. So B squared is 12. No need to take the square root. We're looking for B squared. You go right up here and you plug in 12, and that would be your answer. Okay?